Hello, my name is Sue. I am a solutions architect at iMerit. Thank you so much for joining my session on maximizing dataset potential, challenges, considerations, and best practices. Just a brief introduction of myself. I am a solutions architect. I mainly work on computer vision applications for autonomous vehicles, robotics, and geospatial analytics. Previous to this role, I was working at a geospatial analytics company where I built the data operations team and managed a group of 10 analysts. So let's jump right into it. So first and foremost, for those who are not familiar with the computer vision algorithms and machine learning space, I just want to give you a quick introduction to the use cases that I personally have worked on and continue to work on. So a big client base of mine are autonomous vehicle companies, or those who are making software for the autonomous vehicle space. Also, as I mentioned, I was a part of a geospatial analytics company using not only satellite imagery, but aerial imagery, drone imagery in order to analyze what is happening on and to the Earth. And also warehouse management using cameras and data sensors, not just warehouses, but anything that requires management of physical assets, and that can be at a warehouse level, a ship level, a store level, or even a coal mining plant level. So this session is about maximizing the potential of datasets. For the maximization of the potential for datasets, I want to consider 4 factors: the data, instructions, tools, team, and the work. So there's a little picture on the side here. As you can see, there are individual monkeys annotated as individual objects, groups of monkeys annotated in these bounding boxes, and semantic layer of the water that they are sitting in, just to give you a visual representation of the type of data that I often work with. So my first recommendation for maximizing your dataset potential is know your data. So let's take, for example, this particular dataset. This is a group of open source data that I pulled to train a team on autonomous vehicle semantic segmentation use cases, as well as instance segmentation. So let's go through what are the most important aspects of the data or this particular data set. So first and foremost, in order to maximize the potential of your data set, you want to be able to clearly divide between clean and dirty data. So what does that mean? So clean data, it has to be usable. The whole point of creating or using the visual data for humans to annotate is for us to be able to predict what humans are capable of doing later on with computers. So first and foremost, you need to be able to have correct processing of the data. So let's say you took an image with cameras. What if the rendering was incorrect? What if the filtering was incorrect later on? This really impacts how the algorithm will perform later on. So make sure the processing is correct. Visual clarity. For computer vision applications, everything is visual. We want to basically challenge the accuracy and precision of a human's ability to identify something. So if the image itself is not visually clear, then it can make it very difficult for the algorithm to perform well. And third, business relevance. If you're trying to identify or create an algorithm that keeps pedestrians safe when crossing the road, you want to have a lot of images that are specific to humans crossing roads, not of, the curb or vegetation or areas where humans aren't really, there isn't high foot traffic for humans to walk on or pedestrians. So it's really important to make sure that your data has business relevance. So on the flip side, dirty data is if there's any processing error, maybe the data didn't render properly, blurriness, maybe in the process of capturing the data, there is no processing error, but the camera moved too fast so you can't identify what you're looking at, or totally irrelevant data. As I mentioned, if you're trying to keep pedestrians safe, you want to have a large data set of pedestrians interacting or in and around cars in different circumstances. So when you get a data set, likely it's not always going to be a 40-60 split, but you're going to get some subset of the data. It's really important to identify what this clean subset is so that you don't spend so much time going through the 60%. So you want to make sure that you have a quick filtering mechanism to say, this is the clean and relevant data that we want to work with. This is the dirty data that we might have to use because maybe there's a lack of data or maybe there's another use case you want to draw from it. But for the time being, it's good to separate them so that you can focus on your goal. So next is volume and diversity. These are the kind of questions that you're going to encounter when it comes to the volume of data. So first, is there high volume or is there a low volume? Do you have a single client who is providing you with a small subset of their data, hoping that you'll provide a certain level of proof of concept results so that they will feel confident to move forward with you? Or are you a research institute that has a partner or you're part of an organization that's getting a large feed of data? And so generally the volume is high. Next, are you getting a one-time data dump or are you getting that continuous loop of data? Are you getting it from one source, multiple sources? And lastly, is it a regular stream of data to you or is it sporadic? So in the case of, let's say, retail, there are high seasons and low seasons where people are shopping more and there are bigger sales when seasons change. There's going to be a spike of data. So that's very important for the retail space. In the case of, let's say an autonomous vehicle company wants to create autonomous capabilities for one particular location in the world, let's just say San Francisco, then you might get regular data because they care about the data all year round and the conditions of San Francisco all year round. So you might get a regular feed. In terms of diversity, here are just some factors that contribute to diversity, although not all. So density of a particular image or video. So whatever it is that your subject is, let's say again, pedestrians walking and near vehicles or where vehicles are also located. Are there a high number of pedestrians, a low number of pedestrians? In the case that you want to identify multiple or a variety of objects, are there a low number or different types of objects, like there's only humans and cars, or are there humans, cars, vegetation, animals, other non-motorized vehicles, etc.? What are the conditions of the particular data or the circumstances that the data was taken in? Is there snow? Are there different weather conditions? Is it a different time of day? Is it the daytime, nighttime? This all affects what the data looks like visually. And then the setting, are we looking at a countryside, a dense urban location, areas where cars are not allowed, areas where only cars are allowed, parking lots, etc.? And of course, the capturing device. There are a variety of capturing devices. Obviously, there's multispectral for images that you can take just on your phone. There's different kinds of radars that capture data in a active way in order to capture maybe a 3D rendering of the area around you. So really what you want to do is find that sweet spot between the volume and diversity. Let's say you have a really high volume, but a lot of the data is repetitive. It's really not going to help your algorithm perform better if you continue to give it regular situations, easy to detect situations. When cars are going really slow, where there's very, very few people, these aren't the kind of cases that are going to improve your algorithm. So you want to stress test your algorithm by providing them with a variety of settings and conditions and number of objects and amount of the density of the objects within the image. So there is value in both all different types of volume levels and streams of data, but there's also And there's also merit in the diversity of data, but there really needs to be an intersection. For example, if you have really low volume and you're trying to capture all of the diversity, you simply won't have a sample size large enough in order for you to have the algorithm perform the way that it needs to. It just simply doesn't have enough examples. So please keep that into consideration. If you have low volume, more than likely your hands are tied and you'll have to run the annotation campaign for the full volume. Next, organization and prioritization. This is incredibly important and I think a step that is often missed. So it's really important to plan what your goal is so that you are hitting all of your targets one by one and you're making sure that you're picking all the lowest hanging fruits, or if you can't, you know where to shift to very quickly. If every time you shift priorities because of a blocker requires so much individual planning, this is going to really slow you down, and instead of spending time annotating the data or contributing to the data quality, you're going to be having to stop and plan too many times. Of course, it's important to recursively look at your data and organize it and take into consideration new factors. But it's really important to have that high-level view that guides you, that North Star. So take, for example, the autonomous vehicle case again. In this particular case, let's say the volume and complexity of the data for pedestrian safety is really large, such as this larger red box, but it's high priority represented by the red. So you know that this is kind of going to be a difficult project, but it's a high priority. In the case that you're looking at the turn-related collision, it's high priority, but it's relatively smaller in scope and easier to execute on. So maybe this is something that you want to push forward first, so that you can work on the pedestrian safety kind of in the background. And then there are other priorities, right? So lane segmentation of major roads, all vehicle types, capturing all vehicle types. This is highly intensive to get all vehicle types across every single country, and identifying them in all of the different models. It may have some business use case, but maybe it won't be as important as the safety of individuals who are driving a vehicle or around a vehicle. Again, countryside road conditions, traffic lights or traffic signs of all countries, extreme weather conditions. It's really important to be able to focus on the area that you want to impact and make sure that your data creation process is aligned with that goal. Of course, once you have a good sense of how you want to create the data for one area, then you'll have the insights to maybe push on to another subgroup, but I really recommend trying to fully understand a smaller subset of data with fewer variables before expanding further. So instructions. When I say instructions, I mean instructions on how to actually physically annotate the data. So it's important to be clear and ready for change. Basically, like anything, if you're building a house, you want to be clear about what the layout is going to be like, what kind of material that you need. But in the case that they run out of the material, you don't want to stop your entire project. You want to be able to have replacement objects, or maybe you want to make another room or something. You want to be able to be ready for that change and assess whether it's feasible or not. So taking the previous image, now we have 40% of the data that we decide to move forward with. It's clean, it's diverse, it's organized, and prioritized. So these are the contributing factors to making sure that you have guidance when it comes to the data set you're about to create. So make sure you have a strong project guideline. Basically, you want to be very clear about how what is being annotated, what is considered an object that should be annotated. For example, if you want to annotate all vehicles, that's different from annotating just sedans or just vans. So being very clear about what you're trying to capture in your data set. Being very clear about the tool configuration and the usage. So You may have a general idea of what you want to capture, but when it comes to configuring a tool, you need to be very, very explicit. This is what you can and can't do. And of course, for the individuals who need to do the annotation, they need to know how to use the tool. So make sure that you have the guidelines for actually using the tool and actually going through the motions as well. In the data annotation space, images and videos are incredibly important because there are going to be a diversity of cultures and languages represented when working on the data. So it's always helpful to have visual cues over very verbose text. A lot of the times when we're working with things, it may be very obvious what a vehicle is, but there are so many different types of vehicles out there in so many different circumstances. It's really helpful to have visual examples saying, hey, these are going to be anomalous cases, and this is how we want you to handle them. And then lastly, as mentioned before, ease of updating the instructions. Things are going to twist and turn, and although there is a limit to how much you can change, you still do need to account for the change. If your machine learning engineer wants to change the direction a little bit, you don't want them to wait 6 months to do it. You want to be able to have it in a more reasonable time scale. So make sure that it's easy to version the data set that you're working on, updating the project guidelines and versioning that as well, and implementing the new project guidelines to the next set of data or next project. So when you go through this entire process, inevitably the clean data hopefully will become cleaner. The clean, diverse, organized, prioritized data, once it's annotated with the correct project guidelines, tooling specifications, etc., you're likely going to have a sliver of the data be filtered. This is really important because when you can't account for something in computer vision algorithms, it's really important to be consistent with your data, and you don't want to make a sloppy guess unless you have a catch-all superclass that can capture a vehicle. So if you say, hey, we want to capture absolutely all vehicles, you may have a superclass called vehicles unknown, and make sure all the other vehicles are classified in the subcategories. If you can't do that, it's better to filter out that particular data set and push it into the unknown data set so that you can process later on. So next, tools. Tools are very important because it can really make or break a project in terms of data quality and data management and the speed of the overall project. So when you're looking at tools, I really recommend checking for function and flexibility. So what does that mean, function and flexibility? So first, you want to think about integration. What is integration? You want to be able to take in data and receive the outputs in a relatively easy way or straightforward way that is also secure. So always ask, whether it be your data annotation company or your tooling company, what is the integration? What is the overhead on your side to integrate with their tool and conduct the annotation? Second is configuration, or a second part of the first is configuration. So let's say that you have a class list: car, people, vegetation, road signs. But suddenly you want to add animals because it's a high priority in areas where they have a lot of pets. You want to be able to have some level of flexibility to change that. If you have to rely on your tooling company or whoever else to make that configuration, it can cause massive delays. And if you have, let's say, 10 people or even 100 people working on your project and you're waiting for that configuration change, it can cause hundreds, maybe even thousands of hours lost in a blink of an eye. So you really want to be able to have some flexibility to go in yourself and do the configuration if need be. Second is data management. I guess there's really two parts to this. You want to be able to slice and dice the data in a meaningful way. So let's say there's a high priority data set. Anything with humans in it is a high priority. You want to be able to slice the data set for the images that have annotations of humans. That's one way of managing data. Another way of managing data is checking the status of where team members are working, how team members are working on the data. So is this the first pass of the annotation? Is this a QA round? Is this the secondary QA round due to project guideline changes. You want to be able to keep track of that in a meaningful way. And of course, get metrics. How is the team performing? Are they improving over time? Are they slowing down over time? What is the cause of that? Is it because the images are getting more and more difficult? Is it because there's just human fatigue? And over a long period of time, what is a sustainable time per task what is the sustainable time per task? So being able to not only slice and dice so that you can QA your data and understand your data in a meaningful way, but you also want to have metrics so that you have other factors that can guide you to improving how you conduct your data annotation project. Annotation optimization, this is a really big one. I think a lot of people think of ML capabilities when thinking of annotation optimizations, but there are many, many other ways that annotations can be sped up and the data quality can be improved. For example, when you're drawing annotations of a bounding box and you have to have it be a certain class, if you're repeating that particular class, let's say there's 100 humans, you want to make sure that the bounding box can be drawn without having to click into the bounding box saying this is a bounding box and this is a human and drawing the bounding box. You want to be able to set that in stone, do the annotations, and then when the class changes or the annotation type changes, then change the tool that you're using to go on to the next one. If you have to go back and forth, and you would think that this is a pretty simple thing that tools should be able to account for, but it's not always the case, so just warning you. These are type of things that can really make or break or help you achieve or miss your deadline. Other things are being able to filter the annotations. It's very common for these complicated use cases to have hundreds, if not thousands of annotations, and you want to be able to filter out just the ones that you want to focus on and say hey, today we're going to focus on improving the human annotation class, or today we're going to focus on the cyclist class, etc. If you don't have the ability to filter, it makes it really, really difficult to keep track of what you did and didn't do. And also, if you even want to investigate, you're going to have to look at so many other things, and just the cognitive load that it puts on you to have to keep track of not only what is, but what is not, can make it really difficult to maintain data quality. So really look for these optimization functions within your tool that will that makes logical sense and helps you conduct your data annotation project in with relative ease. ML capabilities. So there are several out there now, and it's very exciting, but I also want to caution you on their performance. I definitely encourage looking into them, testing them out, but also don't take them at face value just because you saw a nice demo. Likely, the type of annotations that are useful for your algorithms are going to be highly complex and very difficult to discern immediately. So that's why humans are annotating it to begin with, right? So some of the ML capabilities that you should look for is video annotation. So basically you annotate the first frame and then it interpolates for the rest of the frames for however number of objects there may be in the video. For single objects in a very high contrast setting, like let's say the car is black and they're driving in a snowy mountain, likely the performance will be much better. But the reality is the data that's useful for you is going to be much more difficult to discern than that. There's probably going to be multiple cars with humans and people behaving not according to the laws of the road. So make sure that you test these functions as they improve over time on more difficult data. And if a tooling company or an annotation company shows you a very simple example, push them to show you examples of more difficult cases. And what's really, really promising is if they first upfront show you how the tool fails, but also show how they deal with that and how they keep your data clean despite these shortcomings that exist today. By recognizing these things, it'll improve their algorithm and ultimately your data set. Other ML capabilities are annotating a single object within an image and it being able to predict all of the other objects within that image with some level of confidence. This is common with clouds for satellite imagery or cars in a busy road, etc. Usually they provide some score for the annotation, and for some things it performs well, for others it doesn't. I don't know what your use case may be, but I would encourage you to test them on several different images and see how they perform. Yes, so be excited. I would say I'm personally very excited about the ML capabilities, but I'm also very cautious, and I'm also I tread carefully, because in the end, if I'm too trusting of the ML capabilities, that can really have a negative impact on our client's output. And ultimately, what we're trying to establish is the ground truth so that we can teach algorithms properly, not necessarily just churn through data. So what do tools do for you today? Without good tools, it may be nearly impossible to identify when the timeline is when the deadline is for your data at a certain data quality level. So again, we filtered out this 5% in the actual annotation process by having really rigorous project guidelines that filtered out cases that are unknown. And so now the question is, how long does something take? And ultimately, a good tool, that has optimization capabilities that help you manage your data sets, that help you integrate well with your with whatever infrastructure you have, will allow for accuracy, precision, flexibility to change, and it'll fit into your time and budget. So something that was just going to be, indefinite will maybe be able to be scoped as 2 to 3 months, for example. Finally, I want to talk about team and work. And really what I want to emphasize is establishing strong communication methods with your team in order to produce high quality work. So what are the factors into team and work? So scaling and readiness. What does that mean? Different types of data tooling companies and data annotation companies will have different capabilities of being able to scale the team, hire more people, and make sure they're ready to work on your use case. Not all companies have a partnership with organizations that do these kind of trainings or preparing team members for computer vision applications. I've been working in this particular field for a number of years, so it seems almost second nature to me. But if someone were to suddenly say like, oh, we need to study the culinary arts, I would be totally out of my depth and I wouldn't be ready. It's the same thing when we have team members, annotators, team leads, managers, etc. We have a partnership that ensures a certain level of readiness for working on this type of work. So you should really ask your annotation company, like, what is that process? What is your scaling process? What is your training process? And I guess I'll jump over to the training and ramp time. So by being able to have a more ready workforce, the training time will inevitably be shorter and will be facilitated more easily. You want to ask your annotation company or your labeling company, what is the training time and what is kind of your average ramp time? If it's something relatively complex and they're giving you a really, really short timeline, they either have high exposure to that and have operationalized it efficiently, or maybe they're being a little bit too optimistic. So always have a number in mind yourself, do the annotation yourself, kind of try to calculate in human fatigue as well. How long does it take you to do an annotation over the course of 1 hour versus 8 hours versus 1 week, or versus every single day or every single work day for the course of 1 month. So these times tend to be different and you want to be realistic in order to be successful. So make sure you have that number kind of in the back of your head or some gauge of it so that you can have a meaningful conversation. Communications and feedback loop. I would say this is really the crux, the pinnacle of what will help you be successful in creating meaningful data sets. The reality is we're only creating data sets for things that are difficult. We want computers to identify difficult things that we're having trouble with today, and that is what creates value in this particular industry. So being able to triage issues very quickly and be very open and honest about what we do and don't know is very important. So what is your communication method? Do you have email threads? Do you have regular meetings? Do you have documents that track progress? Do you have retrospectives? What is that process, and how often do you facilitate it, and who is involved? This is really important for having a good long-term project. For short-term projects, I recommend having very regular feedback loops because there's not a lot of time to go back and fix something, and you're probably on the hook for a very short timeline to deliver some results to your end client. So have really regular feedback loops, and if you need any changes, you need to communicate that to the team as early on as possible. For longer term projects, you might have a little more flexibility, so you don't have to talk so frequently, but once a week to just make sure you're aligned, even if it's just a quick check-in. And then lastly, having conclusive or regular retrospectives. In order to improve in this industry, we really need to take a step back and look at what we have done so that we can ultimately create better processes and think more deeply about the data set. To be honest, I've been a part of many different industries, whether it be autonomous vehicles, document parsing, geospatial analytics for the energy sector, for the retail sector, for deforestation sector. But the reality is I am not by any means an expert in these fields. When you're in this kind of solutions architect position, you really need to have the patience to listen to a lot of different sources and formulate something that captures the essence of the data really well. And if you don't take a step back, it's really difficult to improve upon that. There is this intersection of data operations processes and the actual subject matter expertise. And you need to have a good balance of that in order to create strong data sets. So it's really important to take a step back, evaluate the process in which you use to create the data, evaluate what domain knowledge that you had to create the data, and make sure you fill in the gaps or improve upon it in the next iteration. So in short, the process, if you have a strong team and you have a strong communication method, you'll be able to move on from the low-cost version 1 dataset to the version 2 dataset, which is really focused on data quality improvements, to version 3, where you're expanding or improving upon the guidelines, to version 4, where you have documented, defined dataset for something that is closer to production level. So this is kind of the pilot to production process, and of course you can go through this in many different iterations. So this is making the most out of your data set because you can have multiple uses with the same 35% of the data. You can have the quick and dirty pilot. Maybe your sales engineer needs to pitch something to the client now, and you'll be able to produce something relatively quickly. But you have a process that allows you to jump from one to the other because you have strong communications with your data annotation team. You have good tools, and you understand your data really well. And you can move through this process one by one, and create really different versions or almost different products even. Unfortunately, when you do not have good communications and you don't have a strong process for creating your data, you can be stuck in the data quality improvement stage where you're constantly trying to improve on the data quality instead just the data quality of the original guidelines rather than improving over time. So it's really important to be able to have that strong communication so that you can move on to the V3 and the V4. So here, if you do have that strong communication, ideally you'll be able to have documented, defined data set where in many of the cases with our clients, they're publishing their data. They're not just creating an algorithm where they don't have to answer for it. They actually do need to know how the data was created, what tool was used, what was considered, etc. So in conclusion, it's really important to know your data. It's really important to be clear and ready for changes when it comes to your instructions. So be flexible. When you choose your tool, you should evaluate at least a few tooling companies. There are quite a lot out there, and the tools are improving every day. Check for their functions and their flexibility. Of course, good UX UI is very important too, but in the end, what's going to help you is actually having the capability of making that data set. So keep that in mind. And then finally, team and work, establish that communication method. Establish those communication methods because it's going to help you not get stuck in the data improvement rework phase, but also expand upon your guidelines and really learn from your data and create something that can make a meaningful impact in your algorithm. So thank you so much for joining my session. I would love to continue to engage with everyone who has joined this session and who want to have a continued dialogue. So send me a message if you have a project or a specific use case you want to go through a planning exercise. If you just want a sounding board, or you're just starting out, or you're a relatively small startup and you really want to get a better understanding of how to set up data operations and make sure that you don't get into some of these pitfalls. Two, if you want to evaluate your current process and see if you can further maximize on your data creation process, feel free to reach out to me. Three, you disagree or you want to provide me with some feedback. I would really appreciate your honest feedback to me. Four, if you're a tooling company who wants feedback on your tool, iMerit works with a variety of tooling companies, so please reach out if you want a little bit of feedback. And five, you want to have an in-depth discussion about the industry in order to improve your data creation process. Maybe you don't know which data annotation company to go with. I will honestly give you a candid answer despite being affiliated with iMerit, so please feel free to start an open dialogue with me. So it's very easy to reach me. You can email me at sue@imerit.net or connect with me on LinkedIn. If you type in Sue Yang, you should be able to find me, but in any case, linkedin.com/in/Sue Yang. Thank you so much for joining my session. Please do not feel shy to reach out, and I'm excited to engage with you further. Bye, have a nice day.